Hello everyone, welcome back. Welcome to the second video of Fourier transform. In the last video we discussed about basics of Fourier transform and mainly we discussed problems related to Fourier transform and inverse Fourier transform. In this video let us discuss problems based on Fourier sine transform, Fourier cosine transform and how to solve integral equations. Let's quickly recall the formula which is required for this video. The one thing is Fourier cosine transform and the formula is integration 0 to infinity f of x cos ux into dx and notation is fc of u. And if you want to find the inverse Fourier cosine transform, formula is 2 by pi integration 0 to infinity fc of u cos ux into dx and as usual the notation is f of x. And if you want to go to the Fourier sine transform, formula is integration 0 to infinity f of x sin ux into dx and notation is fs of u. And to find the inverse Fourier sine transform, formula is 2 by pi integration 0 to infinity fs of u sin ux into du. And the important observation is when we discussed problems on Fourier transform, the limit is minus infinity to plus infinity. But here throughout the sine and cosine transform, the limits are 0 to infinity. So these observations you have to remember. With this few basics formula, now we will move on to the problem section. So the first problem goes like this. Find the Fourier sine and cosine transform of f of x. It has two values. One is x from 0 to 2 and in other cases it is 0. So first we will find Fourier sine transform, then we will move on to the Fourier cosine transform. So let's begin with Fourier sine transform. Formula is fs of u equal to integration 0 to infinity f of x sin ux into dx. But in this case the function f of x is defined only 0 to 2, right? And f of x is x sin ux into dx. Now we have to integrate as usual Bernoulli's rule or integration by parts. We will take x as first function, sin ux as second function. So first function as it is, integration of sin ux is minus cos ux by u minus differentiation of x is 1. Again we have to integrate this function minus as it is, integration of cos ux is sin ux by u but one more u is there, so u square. Upper limit is 2 and lower limit is 0. So apply the limit. Here minus 1 by u is constant. When you apply upper limit, what you get? 2 times cos 2u minus lower limit is 0. So 0 into anything 0. Minus into minus plus 1 by u square is constant. Take outside. Upper limit is 2. So it is sin 2u minus lower limit is 0. So sin 0 is 0. Simplify this. We get the answer as sin 2u minus 2u cos 2u divided by u square. So this is the value of Fourier sine transform. Now quickly move on to the Fourier cosine transform. Same thing, write down the formula first. It is fc of u equal to integration 0 to 2 actually, because it takes only from 0 to 2, right? F of x is x cos ux into dx. Same procedure, apply Bernoulli's rule and simplify. You get the answer as 2u sin 2u plus cos 2u minus 1 divided by u square. So this is the answer for Fourier cosine transform. Here also procedure is same. We applied Bernoulli's rule and we simplified as upper limit minus lower limit. So these are the answer. So now we will move on to the next problem. Find the Fourier sine and cosine transforms of f of x equal to e power minus alpha x, alpha is greater than 0. Again here also we want both sine and cosine transform. Let's start with sine first. Fs of u equal to integration 0 to infinity f of x into sin ux into dx, but here f of x is defined for all values, so 0 to infinity as it is, f of x is e power minus alpha x. Now how to integrate? So here we cannot apply Bernoulli's rule, right? Because if you take any of the function as first and second, both are non-vanishing terms, right? How many times if you integrate or differentiate, both terms are non-vanishing. So we cannot apply integration by parts or Bernoulli's rule. But we have a standard formula, that is integration e power ax into sin bx dx is e power ax by a square plus b square into a sin bx minus b cos bx. And in this case, the value of a is minus alpha and the value of b is u, right? So substitute these two values here and apply the limit as 0 to infinity. So we apply the formula. So then we have to simplify, but upper limit is infinity. When you apply upper limit infinity, so you get e power 0, that is 1. But when you have lower limit as 0, that is 1. But remember, when you apply upper limit, that is e power minus infinity, that is always 0. Remember, but e power 0 is 1. So apply all these things, simplify, you get answer as u by alpha square plus u square. So this is the Fourier sine transform. Similarly, we have to go for cosine transform. Formula same, f of x into cos ux into dx. Again f of x is e power minus alpha x. Again we have exponential cosine function. So again we have to use the formula. The formula goes like this: e power x into cos bx into du. It is e power x by a square plus b square into a cos bx plus b sin bx. Here the value of a is minus alpha and the value of b is u. Apply these two values, simplify. Note that e power minus infinity is 0 and e power 0 is 1. After simplification, you get the answer as alpha divided by alpha square plus u square. So this is how we have to solve the problems. Let's take one more important problem. Find the Fourier sine transform of f of x equal to e power minus mod x and hence evaluate integration 0 to infinity x sine mx divided by 1 plus x square into dx where m is greater than 0. Now the first part is very similar to the previous problems. As usual, we have to write down the formula of Fourier sine transform and we have to find the answer. But second part, again it is the evaluation part. As we discussed in the last video, whenever they ask the evaluation part, we have to go for inverse Fourier transform. But specifically here we are dealing with sine transform. Therefore, here to evaluate this particular integral term, we have to go for inverse Fourier sine transform, and accordingly we have to change the variable. We have to get the answer for this particular term. So let's begin with the first part. So write down the formula. Fourier sine transform is integration 0 to infinity f of x into sine ux into dx, and the value of f of x is e power minus of mod x. Since it is a mod term, we have to split. If x is negative, we have to take minus of x, but here x takes only positive, right? 0 to infinity is a positive coordinate, so instead of mod x we can write x only. So it becomes e power minus x into sine ux into dx. So the reason is very simple. When x is greater than 0, mod x can be written as x only. So there is no difference. Again, to integrate this, we have to use the formula e power ax into sine bx formula, what we discussed in the last problem. Here the value of a is minus 1 and the value of b is u. Apply, simplify, and upper limit is infinity, lower limit is 0. Apply these two limits and you get the answer as u by 1 plus u square. So this is the first part. Now we have to find the deduction evaluation part. So as usual, we'll start with inverse Fourier transform. So what is inverse Fourier sine transform? First we write down the formula. It is 2 by pi integration 0 to infinity fs of u into sine ux into du, and the notation is f of x. So substitute the value of fs of u, that is u by 1 plus u square sine ux into du. Will shift 2 by pi to RHS, so it becomes pi by 2 into f of x. And to get the required answer, we'll take x as m. And obviously f of x is e power minus mod x or e power minus x, so it becomes e power minus m, right? Therefore, the integral is reduced to u into sine u m, so it can be written as sine mu divided by 1 plus u square into du, pi by 2 into e power minus m in the RHS part. Now, to get the required answer, we will change the variable from u to x. So we get integration 0 to infinity x sine mx 1 plus x square into dx. That is what we want, and the answer is pi by 2 into e power minus m. So this is how we have to get the required deduction. Now let's take one more interesting problem. Find the function f of x whose Fourier cosine transform is f of alpha, here capital F of alpha is a minus alpha by 2, 0 less than or equal to alpha less than 2a. In other cases, that is when alpha is greater than 2a, answer is 0. Now understanding of this question is very important. See, we have to find the function f of x. So given capital F of alpha. So whenever they ask f of x, which means to say we have to find the inverse transform, right? So that's the first observation. And specifically here answer denotes Fourier cosine transform. Therefore, to find f of x, we have to go for inverse Fourier cosine transform. So that observations we have to keep in our mind. Therefore, let's start with the formula. To find f of x, we'll start with inverse Fourier cosine transform. So what's the formula? It is 2 by pi integration 0 to infinity f of alpha into cos alpha x into with respect to alpha. So be careful, here they have given the term d alpha, and here by the definition of the given function it defined only 0 to 2a, right? In all other cases it is 0. Therefore, integral change to 0 to 2a. F of alpha is a minus alpha by 2 into cos alpha x into d alpha. Again product of two function. To get the required integral answer, we'll start with Bernoulli's rule by taking the first function as a minus alpha by 2 and second function as cos alpha x. So 2 by pi is constant, first term as it is, integration of cos is sin alpha x, here x is constant because we are integrating with respect to alpha, minus differentiation of first, a is 0 minus alpha is variable, so minus 1 by 2, integration of sin is minus alpha x, x into x, x square. Lower limit is 0, upper limit is 2a. So apply the limits, simplify, you get the answer as 1 by pi x square into 1 minus cos 2ax. When you simplify this, 1 minus cos theta is 2 sin square theta, right? So it is 2 times sin square ax by pi x square is the required answer for the given function. In the same way, let's take one more problem. So this is also similar to the previous problem. So we have to solve the integral equation. What do you mean by integral equation? The meaning is very simple. Here we have one unknown function, right? F of x. When you multiply f of x with cos alpha x and integrate with respect to x from 0 to infinity, we get the answer as e power minus a alpha. Now our job is to find this unknown function f of x. So this type of equations are called integral equation. So now our challenge is to find the value of f of x. How to find f of x? Again, same logic we have to use what we have done in the previous problem. Of course, to find f of x you have to go for inverse transform, but which inverse transform is the question. Since here they have given in terms of cosine function, so it is sure that we have to find the inverse Fourier cosine transform to get the required answer for f of x, right? So that is observation you have to remember, and this e power minus a alpha represents f of alpha. Since it is a function, you have to go for this as f of alpha, and we have to find f of x with the help of inverse Fourier cosine transform. So as usual, write down the formula first. The formula is 2 by pi integration 0 to infinity f of alpha cos alpha x into t alpha, and f of alpha is e power minus a alpha cos alpha x into d alpha. Again we have to integrate this. As we discussed in the last problem, it is of the form e power x into cos bx. Formula is e power ax by a square plus b square, a cos bx plus b sin bx. The value of a is minus a and the value of b is x because we are integrating with respect to alpha. And simplify, upper limit is infinity, lower limit is 0. So the answer is 2a divided by pi into a square plus x square. So this is the required answer for f of x. Let's take one more problem and we'll wind up. So solve the following integral equation. Again same problem what we have done in the previous case. Integration 0 to infinity f of x sin alpha x into dx takes 3 values, right? Again you have to find f of x value. Since it is sine function, it is sure that to find f of x we have to start with inverse Fourier sine transform, right? Fine. So this is the given function. Let's write down the formula first. It is 2 by pi integration 0 to infinity fs of alpha sin alpha x into d alpha. But the function has three subfunctions. 0 to 1 it is 10, 1 to 2 it is 20, and for alpha greater than 2 it is 0. Therefore, we will split 0 to 1 it is 10, 1 to 2 20, in other cases it is 0. And we have only one function because 10 and 20 are constant. So integration is very simple. Integration of sine is minus cos, and in the first case limit is 0 to 1, and second case the limit is 1 to 2. So apply upper limit minus lower limit. Simplify, you get the answer as 20 by pi x into 1 plus cos x minus 2 cos 2x. So this is how we have to solve integral equations. So these are few homework problems, just try to work out. These are the similar problems what we have discussed in this particular video. So overall in this video we discussed the problems based on Fourier sine transform, Fourier cosine transform and its inverse, and we also discussed the solution of integral equation. With these two videos we come to the end of Fourier transform contents. Thank you so much. Have a nice day.